we left off, we were talking about this one here compared to this one here. And the red one, that's in vertex form, because I can see the vertex right away. It's negative 4,9. And this one is in general form. These are a lot easier to graph by hand, because you know where the vertex is. That's where you always start. And this is, well, both of them could be typed in on a calculator to be graphed, so it really doesn't help anything to put it in this format. But the main thing this helps with is it's got A and B and C in it. It's got a 1 here, an 8 here, and a 25. Where do you use those? Quadratic formula. Very good. Okay. So this is general form is handy for that. And it also has this number, which is kind of important on this, but not important here. Why? Because this one, in this kind, it's always the what? The y-intercept. That's correct. It's the y-intercept, because if I stick in x is 0 here and here, it'd cancel it out. So the y-intercept is one good thing about the general form. And general form also does that A, B, and C part. That's handy for quadratic formula. All right, I'd like you to try this purple one right here. Notice that 5 is kind of annoying because it's out in front. Well, move it to the back side of the equation. And when you move it to the back side of the equation, should you bring the negative or not? No, you should not, because that negative is stuck to the parentheses, not to the 5. So that when you move that 5 over, keep it positive, so to speak. All right, and then multiply it out and tell me what the purple one is in general form. I'll pause while you do that. Okay, so I rearranged it, and then I split this up into the two parts that make it up, and then I'm going to FOIL it out. And I still have this negative at the front. X squared minus 8x, I'm skipping a step here, that's dangerous, and then plus 16. And then there's a plus 5 at the end. And then the negative has to factor into everything. Remember that? So it's negative x squared, positive 8x, negative 16, and then plus a 5. And then at the very end, you put these two together, negative x squared plus 8x, minus 11. I know at least one person got tripped up by the minutia there. Raise your hand if you got it right. Good. All right. The last thing that we have to talk about here is evaluating functions at a given point. If this is a function and I want to evaluate it at x equals 1, it's really easy. What do I just have to do? Just stick in 1 for x. That's all I got to do. So f of 1 gives me that. Would you please calculate that? I'll give you a second. You can do it in your head if you want to. Who can walk me through it in their head? Well, this is this, and then this is that. 1 plus 4 is 5. Good. 5 squared is 25. Plus 9 is 34. Raise your hand if you had that one right. Good. Okay. Then this one is just, all you have to do, same thing, stick in 1. That'd be pretty easy. Don't need to practice that, I don't think, judging by how many of you got the last one right. How about this, though? That's a function, but it's just a graph of it. And then if I say evaluate at x equals negative 1, here's how I want your brain to work in this situation. Well, let's see. X is this line. This is the x-axis. And I got to find where x is negative 1. Well, it's right here. But there's nothing there. Oh, he must mean that I should go down there and figure out what is at x is negative 1. And it's x is negative 1, but y is negative 3. So I could say that the answer is negative 3. Or I could say that the answer is negative 1 comma negative 3 is that point. All right, I'd like you to try this one. Evaluate it for x equals 3. At x equals 3, what did you have? x equals 3 was right there. And you followed it down to negative 3. Wait a minute, but didn't we, the last one was at negative 3. We had negative 1 going with negative 3. Is that allowed? Doesn't that break the rule about functions? Why doesn't that break the rule about functions? Because I got two different inputs giving me the same output. That's okay. You can't have the same input giving you two different outputs. If this had been one giving me 5 and one giving me 6, that's not allowed. If you have the same output, it has to give you the same, or one input, sorry. You have one input, it better give you the same output. If it gives you different outputs, one gives you a 5 and then one gives you a 6, that breaks the rules and it's not a function anymore. Okay, last way, the way I want to stretch your mind here is, what if I said y equals negative 3? Evaluate this function for y equals negative 3. Somebody walk me through how your brain figured this out. Hamish. I find a spot where y is negative 3. Okay, here's a spot where y is negative 3. Then find the points that would connect on, okay, if I make this a line, find the points that would connect on that line. Okay. So here's my two answers. How do I say those answers? This one right here would be negative 3 comma negative 3. And which part of that did I give you? I gave you y equals negative 3. So it's this first one that matters then, right? And how about this point right here? Negative 1 comma. Oh, you're right. You're right. I messed that up. This was positive 3, negative 3. I'm sorry. This is over 3 to the right and then down 3. So that's positive 3. So that means that that is my final answer. I was given the y equals negative 3, and I figured out that x must equal 3. And there's another thing it equals. It equals negative 1. So here's my two answers. And the important parts of them are here because I was given that y was negative 3 part. All right, so to recap, when you have a quadratic, you know a lot of stuff about quadratics from before. You know how to make a quadratic. Oh, hold on. You know how to make a quadratic with the over 1 up 1 thing. Over 1 up 1, over 2 up 4, etc. You know where their vertexes are found. Like here we have the vertex of 3 comma 1. When you change by multiplying out quadratics and you get these new quadratics, they are in general form once they're all multiplied out. And you should always line them up in order with the biggest exponents first. And general form is good for y intercepts, and it also gives you the a, b, and c that you can use in the quadratic formula. That's the main stuff I needed you to know. Do you understand all that stuff? Okay, good. Then we're done for today.